Good afternoon, everyone, and thank you for joining us for the Maximise Your Mind Value with All Controller webinar. Before we begin, to ensure that all registrants have successfully logged in and are able to view and hear the presentation, please use the raised hand button on the left side of your screen to verify that you can all hear me and see the introductory slides. Okay, we're looking good. If you do happen to experience any technical issues during the presentation, please use this raise hand button and we'll attempt to assist you. Otherwise, you can contact the conferencing support team whose details are featured in your confirmation email. We'll allocate time after the presentation for a question and answer session, so if you have any questions throughout the presentation, please enter them into the chat box on your screen and we'll do our best to address these during Q&A. Our speaker today is Ben Heather. Ben is an executive consultant with CAE Mining. He is a mining engineer with over 30 years' experience in the design and application of mining software and has contributed a great deal to CAE Mining's suite of products. Most recently, Ben has been looking at how CAE Mining can create software that can be configured to carry out particular workflows. And the first product to deliver this is All Controller. Thanks, Ben.
Can you hear me? Oh, come on, thing.
We can hear you now, Ben.
Jolly good, and I hope you can see the slides too. Yes, good afternoon, everybody. This session is about All Controller, which is a new product that we have for open pit grade control, and it's a product designed for use by mine geology. And the intention here is to make routine ore control tasks as easy as possible, but without sacrificing any complexity that might be necessary in the modeling or the other calculations that go on within the ore control process. I've got about 2 slides before we start looking at the product. And the first one here gives you a bit of an overview of Ore Controller. It's built as a multi-user system. It's a bit of a departure in grade control systems. It's built around a central database which provides us with very reliable data management, and the software itself has been configured to make it especially quick and easy to allow geologists and technicians to use it with very minimal training requirements and to be able to produce results quickly. Because as you know, the time between drilling, blasting and loading is as short as possible, and therefore grade control geologists have to work quickly to produce their results. The system is designed so that we can produce repeatable results from each user all the time, and it's activity-based and implements a managed workflow. There is a standard workflow in Ore Controller that I will show you, but it's highly configurable, and it's possible to add or remove various activities from the system to make it much more suitable for each operation. Being activity-based and using a central database, there's no need for the user to remember or to type any file names and to get used to a file naming convention, because that inevitably leads to errors. The system is designed so that activities can only begin if all the data for that activity is available. The system is fully audited. The database allows multiple revisions of files to be checked in, and each activity has a full history of who carried out the activity, what data they used, and what the result was. And you will notice, if you're familiar with our other products, that Ore Controller is built on top of our Studio product. It uses components from Studio. It is not Studio, it's a separate standalone product, but it uses components from Studio. And that should give you the confidence to understand that it doesn't sacrifice power in modeling or design for simplicity. As I mentioned, it's a multi-user system that uses a central database, and typically it can support 5 to 10 users if that's necessary, but it works equally well as a standalone system. But in any configuration, there is a logical split between the server and the various users. So this slide shows that we have 3 users in this implementation, And as each user connects to Ore Controller, they connect through their local network to a server, and that server will manage a database of files and information about the process. And when the user starts an activity within the Ore Controller system, their local copy of Ore Controller contacts the server, which queries the database to see if the relevant data is available, and will then transfer the necessary files down to the user, where the user will carry out the activity. And when the activity has been completed successfully and the user clicks the complete button, then the changed data is sent back through the database, sent back through the network to the database. And while a user may be processing a particular blast, the database locks all that information to that user. So it prevents two users from trying to do the same task at the same time. Okay, I promised you 2 slides, and that's the 2 slides that we have. So let's have a look now at the product itself. And this is as it appears when it starts up. You'll notice that we've got the user interface is divided into 4 columns. On the left-hand side is the most important. We have the activity selection and the context selection areas here. This is the data I'm going to be showing you is an iron ore demo, and is based on one of our sites in West Africa. The second panel here is where the user interface for each activity will be shown. The main panel here, of course, is the design window, and on the right-hand side we have a palette menu of various commands. And this can be customized to add particular commands that you might prefer to have built into your system. So let's go back over to the left-hand side here, and I'll explain what we're looking at. First of all, you can see there's a mixture of folders, icons, elements with a folder icon, and these elements below which have a start button against them. And these represent, as you can probably guess, the main activities in the grade control system. Just above it here is what we call the context selection panel. And here the division is into pit, bench, and blast. This is representative of what we would normally do with a grade control system, but it can be changed. For example, if you want to specify a pit, then a cut, then a bench, and a blast. Or if you only have one pit in your operation, then we just remove the item that says pit. And the user interface below is sensitive to the selections that you make here. So on bench 324, I have currently 5 blasts that have been entered and are being processed. And if I switch to blast number 2, you'll see that the UI changes down below. And this means that I can't start the blockout activity because I don't have the relevant information for blast number 2. In other words, I haven't processed the block, created or updated the block model in the area that's relevant to blast number 2. If I go on to blast number 3, you'll see that processing has been completed, and the start button there means that I can rerun that activity if I wish. I'm going to be working our way through blast number 2 in this demonstration. But before we do, let's have a little bit of a look at some of the other areas within the menu here. First of all, the administration is just an area where there are a group of activities for defining benches, material types, grade fields, all the parameters to do with modeling, and zone codes and so on. There's also a section to do with quality control, which is something that we do before we remove before we ship it. Also, the administration area is normally restricted to one person, 1 or 2 administrators in a particular implementation. And for the other users, then that folder would simply just not appear. We'll take a quick look next at the data area. And again, the data area would normally be configured to be suitable for your particular requirements. Ore Controller uses data from 2 main sources. The first of these is a series of blast outlines, which are areas going to be blasted and areas that require processing by the grade control geologists. These blast outlines would typically come from your short-term planning system, which might be using CA Mining Studio product or any other system that's on the market today. The next item in this menu relates to drill hole data, and that's because out of the box, so to speak, Ore Controller uses CSV files to recover collars, assays, surveys, and lithologies for the drilling information that you're going to use in your grade control estimation. That's only the lowest common denominator. More normally, we would configure Ore Controller to interface with your drill hole database, and therefore this activity wouldn't appear. The third activity in this list is where we can import to the system surface topography, any fault wireframes, and any other information that's relevant to the process. So those are the reference data files that are used within. So moving along, let's take a look first at drill hole planning. As I said before, the data for grade control comes from blast outlines and also some kind of sampling information. And around the world, sampling information usually comes from one of two sources, either from samples taken from blast hole cuttings, which are very numerous but typically of not particularly good quality for samples, or they come from a grade control drilling program, usually carried out using a reverse circulation or an RC drill. Ore Controller does have a facility here for designing layouts of blast holes, but that's a little bit in the wrong place, as the design of blast holes is normally carried out by a drill and blast engineer, and Ore Controller is a product for mine geologists. So I'm going to show you first the feature in here for RC drill hole planning. And if I click in the blue area of the activity, then the activity itself will preview and doesn't start until I press the start button, which is like a start button on a CD player. When I click the start button, you'll notice some little progress messages appear as the activity contacts the database to retrieve the relevant data for this particular activity and loads it onto the screen. So as we can see here in the design window, this activity has now loaded a mine topography. We have a blue line going across the screen, which represents the intersection of a fault which runs beneath the pit. You can see some existing drill hole information, and you can also see some exploration drill holes colored in red. And what we're going to do is we're going to lay out some RC drill holes in this system to carry out grade drilling so that we can have some information for modeling. We have a function, first of all, to select and set the drill hole pattern. So I'm going to change this to a 10 by 15 pattern and change the hole spacing to 15. And I can specify the dip, the hole azimuth. There's a sub-drilling amount, which I'll explain later. And then on the right-hand side, we have information about samples. So now we have a 10 by 15 pattern as well. And we'll move on to the layout section. And I'm first going to zoom in on the area that I want to lay out holes and define a boundary for laying out these RC holes. So I'll draw that boundary on the screen here and close it off. And I'm going to specify that I want to drill these holes from the surface topography, or plan these holes from the surface topography, and get them to run down to this so-called A fault. I now need to specify a direction for the drill hole rows, and there's a number of ways of doing that and a set of string editing tools that I can use, but I'm just going to use this button which specifies a fixed azimuth, and I'm going to specify that the drill hole, the line of holes, first line of holes will run along here like this. Similarly, we have quite a number of tools for placing and editing the planned holes themselves, but for now, since time is limited, I'm just going to use this button to do the pattern layout and select the position for the first hole, and there we have the set of holes that have been planned. We have a VR window to allow us to view what's going on a little better, and as you can see, if I make that slightly opaque, less opaque. There's the planned holes that we've created, and beneath the surface is the blue fault that we're drilling to. And as you can see, each hole has been calculated to go through that fault surface by an amount of 2 meters, which was specified in the pattern. Now, it's also important when you're planning holes to check for proximity against other drill holes. And currently we have 2 sets of drill holes loaded. We have the blast holes and we have some exploration drill holes. And I'm just going to check quickly against the exploration drill holes to find any of these planned holes that pass within, let's say, 5 meters of the existing holes that are there. And pressing the check button just takes a second or so, and we can see that we have 4 areas to worry about. The one that's of most interest is hole number 306, this chap here, which between 3 meters and 23 meters depth is less than 5 meters from DDH 148, and in fact it comes very close at 0.7 meters down the hole, somewhere down the hole. And again, if we look at the design window, you can see how this calculation is being carried out by placing a region around each exploration hole and looking to see where the planned holes intersect that conical region around the hole. It works almost as quickly with blast holes. So if I check against the blast holes, there's several thousand blast holes to check against here, and we should get, in a few seconds, a similar result where we can see that these holes in row 4 do come within the 5 meters proximity limit from the blast holes. Now, if I want to change the positions of those holes, I have some buttons here, or I can go back to the layout tab and reposition the holes there. When I'm finished with the activity and I want to commit that pattern of drill holes back to the database, I use the Save Design button. I haven't made any changes to the database as yet, and if I want to abandon processing, I can use the Stop button here. So you can go right to the end, you can play around with each activity and press the Stop button and not make any changes to the database. But I do want to commit these back to the database, and there they go. There's also a function here to export those holes, which just sends them off to a particular file. So now let's go back and look at blast number 2, which is in an area that's already been drilled, and we want to go through the various activities that will process this so that the production department knows how to load and how to truck this material. First of all, I'm going to create a block model from the drilling information that I have in the region of blast number 2. Now clearly, each mine is going to have different requirements for block modeling, but what we're using here is an example. So if you were to implement Ore Controller at your site, then you would expect us to make some changes in this area here. But for the purpose of this demonstration, the way that we're going to do this is as follows. Here, the blue outline is the blast outline that we're dealing with. And on top of that, we have some green outlines, which represent some geological mapping. And it represents 2 features. First of all, we have a dike that runs across this blast. And then we have another boundary that represents the division between 2 separate geological domains, which are going to be modeled separately. And we have a set of tools here where I can modify these boundaries on the screen based on some mapping that we've done. And if you have another geological mapping tool, then of course we can take information from that and use that information here in creating the model. The next step is to transform these lines that we're using into separate regions. And so I'm going to use this button called Generate Outlines to do just that. There's a little amount here of 2 meters where we stepped the blast outline out before we generated the outlines, just to make sure that we don't get any edge effects. And now, as you can see, we have a number of different regions. So the first of those I'm going to select as the dike and create a 3D block there. And then the region, this region here, I'm going to call domain A. Now, domain A, B, and C, of course, would be modified to suit whatever particular geological domains that you have. And that's as simple as editing a value in one of the configuration files that we use. On the other side of the blast, we have domain B. All of the parameters for creating the model, indeed a little set of macro commands and a sequence for building the model, has already been built into the system by setting up various tables in the administration section of Ore Controller. So in order to create the model in this region, all the user needs to do is press the button that says Create the Model. And Ore Controller then will run through the prearranged steps to fill these wireframes with cells and then to interpolate values in there. And the process only takes a few seconds, as you can see, and we end up with a model that covers the region that we're interested in. This little loaded data function here allows me to turn various items on and off so that we can look in more detail at the model that we've created. And it also allows me to specify different legends. The legend that's showing at the moment is a material legend, which shows the material categories that we've assigned to each of these blocks: high grade with contaminants, various low grade categories, waste, and overburden. But of course, I can show the variations in iron ore grade, or I can show various contaminations such as phosphorus, or indeed something that's a combination of, in this case, a combination of aluminium and silicon together. In fact, anything you can define using a legend in the studio system can be applied here. But I'm going to go back to show the material legend, which is a combination of iron grade, aluminium, silicon, and the other material that's there, any other elements that you like. I'll just quickly show a section through from west to east in this model to show in more detail what we've created. We've designed the system so that we keep these little individual models small, so that they're lightweight, quick, and easy to use. The model has gone from the top to bottom of bench. You can see the topography and that the model has been cut off at the topography, and also add an overburden. So this purple color represents overburden material that needs to be stripped before we get to mining the ore. So I'm quite satisfied with that model, and I'll save that back into the database. And there we go, updating the database. And having done that, we can now move on to the next activity. You'll notice that we have these little flags that indicate that the activity has been run and completed successfully, and that the one for block out a blast is now showing red and says this activity has newer inputs and should be run again. And also notice that the start button for blocking out has now been enabled for this blast. So let's move on to that activity, and we'll look at how we block out the blast. It is possible to come up with an algorithm to automatically block out a blast into the different material type regions. We haven't done that yet in Ore Controller. We've made a prototype to do that, but in talking to customers so far, we've concluded that what people really want is to allow their grade control geologist the ability to block the blast out in their own particular way, and to be able to do it quickly and to get the results that they need and to make changes to it. So we've designed this activity to be as quick and easy as we can make it. So first of all, I'm going to draw some lines across the design that I have. First of all, to eliminate the waste area, and then to divide the rest of the blast with just a few lines into different regions. Notice I don't have to close these off, because the next step to evaluate that will automatically convert these into outlines, do the evaluation, and then characterize each block as according to its material type. So we have 2 high-grade blocks and 2 low-grade but contaminated blocks and 1 waste block. We also have a very quick evaluation report, where we can see each of the blocks has been totaled up. We have an amount of fresh rock with iron, aluminium, silicon, phosphorus. We also have a total for how much overburden needs to be stripped in each block as well. Or we can see a summary in terms of the total amount of different materials within this blast. So 51,000 tons of high-grade and 11,000 or nearly 12,000 tons of low-grade material and 6,000 tons of waste. We can also show that information in an Excel pivot report, and no matter how many times I do this, it always comes up on the other screen. So here we have the same results presented in an Excel pivot table, and there's also a data tab here. So this information can be supplied to a mine reporting system, production reporting system, if you want to do your reconciliation that way. Also at the same time, with the button to produce a pre-configured plotted report according to your own specification and template, and we've made it very easy to adjust that plot a little bit, so I can move the data around so that it's in the place I want, have a little customized table of values here, and when I'm happy with what that looks like, I can press the print button, and that goes off to my printer to be sent for spotting or whatever goes on next. And again, I can nip back to the design view and make some changes to these. So I might cut that in a little bit closer. Might decide to take some more of this material as high grade here and evaluate that again and look at the differences. When I'm happy with that result, then I would commit that to be saved. So let's just give that a little bit more room down here. It's a bit thin for the machines to work. Evaluate that. I'm happy with this now, and I'll save that as a provisional blockout. Now, when you're operating a grade control system, it's very important that you take account somehow of the displacement of material that happens during blasting. And while Ore Controller doesn't have the facility to calculate the amount of displacement that goes on, we do have the ability to apply displacement to blast blocks. So the next activity I'm going to show here is this one, to displace blast blocks. And we're working with the same data again. And there's the results of the blockout that I just completed, the 5 different blocks. The Ore Controller database can contain various displacement vectors to characterize different kinds of blasts. But this is only of limited use because each blast is unique. And because of that, CA Mining has an alliance with a company called BMT, Blast Movement Technologies, in Brisbane. And we have configured this Ore Controller system to be able to access the BMM Explorer database directly. So I can click the button here and go to the database, the BMT database, and recover the specific blast movement vectors for this blast. I'm assuming in this that you understand the BMM system. It's a system in which you place BMMs, blast movement monitors, into additional holes within the blast and locate their positions before and after the blast using an instrument that picks up radio frequency IDs and will give you the 3-dimensional vectors of movement in different places within the blast. And that's the rather unlikely looking set of displacement vectors that were measured for this particular blast. The only steps that I need to do now is to indicate to the activity where is the back line for the blast, and in this case it's along here. And I can define a barrier which indicates that material shouldn't cross this barrier when it's being displaced, just for illustration. And with that information added, I just then can press the button to displace the outlines. And there the system has applied those vectors and calculated the displacement of each of the blocked out regions. It's also numbered the points uniquely and the points, those points and their coordinates are available on a plot, which again you can very quickly position and then print to send to the surveyor to mark them out. Or indeed, if you're lucky enough to be using a high-precision GPS system, these white polygons are the ones that would be loaded down to that system and appear within the loader operator's cab. So if I save the results of that, that goes into the database. There's then a little function here to export those block points in a form. All that does is brings it up in Excel that I can save somewhere, but that can be customized to, again, can be customized to your own requirements. And that's it as far as block modeling, blocking out, and displacement is concerned. The last step in grade control typically would be reconciliation. And I'm not going to be showing you very much to do with reconciliation today, mainly because reconciliation is highly variable in different implementations. But I will just show you quickly how we go to combine the individual block models that have been created for each blast into a model that is used in a reconciliation scheme. Each time I block out a blast, it's stored in the database as provisional. And the list of provisional blasts, blockouts that I have in my demonstration database are these. And I'm going to select those on bench 324 and move those across. So there they are as the blockout. There's the one that we did a few moments ago. And just by selecting those and selecting Update the Dynamic Model, the activity then goes through a procedure which will combine those blasts into a single model, which again chugs through them one at a time, takes just a few seconds for each, and there we have the combined model, which will be then used as the basis for reconciliation. So if I change the legend on here, we can show the blocked out iron grade, we could show the material types, or we can show the original iron grade within those models. So all of that information is stored within the dynamic model, which, as I say, is then fed into a macro or another procedure to combine that information with the mined out surfaces, typically for the previous month and the current surface, and again with the resource model to compare information from different sources. So I'll just save that dynamic model back to the database, and that's really all I want to show you about Ore Controller. I want to make it clear, though, that in summary, the fact that Ore Controller is built around its central database doesn't just give us the multi-user capabilities of the system, it makes it very, very reliable. Not once in that demonstration was it necessary for me to enter a file name to select the blast outline or drill holes or models or anything like that. It's all been predefined. There's a very neat and tidy database which implements a naming convention, and that makes it very quick and easy. Ore Controller was developed in conjunction with a client of ours operating an iron ore mine in West Africa. The system has been in operation there for over 2 years now. It's extremely reliable, and using local geologists who are usually quite junior geologists, they're blocking out and using the Ore Controller system daily, and their senior geologist told me quite recently that they can train a new geologist to use Ore Controller in a couple of hours. The user interface for each blast tells you what you have done and tells you what needs to be done. So the system leads the user through the procedures that are necessary. So that's about that, and maybe now we could look for some questions.
Thanks very much for that, Ben. Okay, so we've had a few questions come through. The first one, do I need to buy Studio 3 or any other CAE software before I can run Ore Controller?
No. If you're aware of the Studio product, then you would recognize that some of the components that we have in Ore Controller are shared with Studio. But Ore Controller is a standalone product which is installed without any dependencies on any other CAE products. I mentioned that we have a centralized database. Ore Controller includes our Minetrust data management system, which is used for all the data and looks after the configuration of the workflow that implements the activities. If you install the system, you get one license for Minetrust Explorer, which is used to install updates to the system. It's used to add or remove users, etc.
Okay, thanks, Ben. We've had another question here. Which geological databases can Ore Controller access directly?
As I mentioned during the demo, the standard system will read drill hole collars, surveys, assays, lithologies from CSV files, and we've done it that way simply because that is the lowest common denominator, and any drill hole database system of any kind should be able to export CSV files that we can then read in. But we have linked Ore Controller to our own Fusion database system, as well as a number of proprietary databases, whether those have been developed by your own organization or they're commercial products. And the queries that are used to extract that information, they're all loaded into a configuration file. So the system can be configured very easily to hook up to pretty much any drill hole database there is. Just as an example, it's quite quick. We linked it up to the database that's being used by a client in West Africa, where they have a database with something over 100,000 drill holes. And for modeling a particular blast, it takes about 15 seconds to extract the collars, the surveys, the assays, and lithologies, and to do the desurveying to calculate the drill holes, to produce the drill hole objects that we need.
Okay, thank you, Ben. Another question that's come through. Can the blockout polygons be sent to a fleet management system?
Yeah, that's the intention. Ore Controller is quite a new system, and we don't currently have any clients who are using it in conjunction with high-precision GPS. But we have created and we've tested a prototype implementation for a Wenco system. And you may also know that CAE Mining is a distributor for DevX products. DevX Smart Mine is the leading operations control system from Latin America, and we will integrate with their system. But so far, no. But Ore Controller is, as I say, it's a new system. I can also see in the chat window a question from Sam about is the system implemented at any site in Australia? Not yet, Sam. But we'd like to change that fairly soon. It's, as I say, it is a new system. It has been in use at this site where we've had their assistance in developing the software. It's been in use there daily for over 2 years. It was implemented in October 2010, and it has proved to be very, very reliable there.
Okay, thank you, Ben. And then just one final question regarding cost. How much does Ore Controller cost?
Typically, the price for an implementation of Ore Controller will be about $35,000, plus there's an amount for configuration and implementation and the initial training. Ore Controller has been built to be highly configurable. It comes with a very extensive configuration file over and above the files that I showed you in the administration area, where you can configure the system for different types of modeling. So all the conventions that are used for drill hole naming, for block naming, legends, plot styles, all of those things will be configured during the implementation. And because the system is built on these discrete activities, then the activities can be, or new activities can be added or removed from the system. We are completing some new functionality for Ore Controller to provide some standard reconciliation functions. But anything that would be considered to be custom development could be slotted into Ore Controller in a way that makes it indistinguishable from the core functionality. But of course, any customization would be charged at extra cost.
Great, thanks very much, Ben. We'll wrap up our question and answer session there. So this marks the end of the webinar. Thank you all very much for attending. We hope you found the content presented valuable. If you did submit a question that we were unable to address, please rest assured that these have been recorded, and we will make every effort to connect with you afterwards. Once today's webinar has wrapped up, you'll be redirected to an online feedback form. It will take no more than a few minutes to complete, so if you do have the chance, we'd really appreciate your feedback on how today's webinar went. We'll be sending out a follow-up email to all of our attendees. This email will provide you with a recording of the webinar, as well as the necessary details to contact us should you have any additional questions. We look forward to hearing from you soon. Thank you all once again for attending CAE Mining's Maximise Your Mine Value with Ore Controller webinar. And Ben, thanks again.
Thank you. Please stand by.